Hello everyone, welcome to another video. In today's video, I will be discussing 50 important Linux questions and answers. So these questions are important for you to prepare if you want to prepare for any interview, be it a systems administrator interview, a Linux administrator interview, be it for AWS cloud engineer interview, your DevOps interviews, even for SREs. Okay, so it depends. Sometimes the interviewer may ask you Linux questions as well, because as I mentioned, Linux is the core of everything, and you need to be really good with it if you want to survive in this domain. All right, so let's start. So I'll start with question number 1. Why Linux is called open source and what does it signify? Okay, so the meaning of open source is pretty simple, that the source code, the original source code of Linux is available to public. Okay, if you want to check that, you can go to kernel.org, okay, which I just opened. So here you have the original source code of Linux. It's called open source because it is available to public. You can use it, you can study it, you can analyze it. If you want, you can modify the original source code as well. You can create your own Linux distribution, and then you can redistribute it to anyone. So that is why it is called open source. Okay, if you see some examples of open source Linux distributions, you can see Arch Linux, Ubuntu, Debian, OpenSUSE, etc. So all these are Linux distributions, and the source code has been taken, and then those source code have been modified, and then they've just created their own version of Linux. Okay, and who's the creator of Linux and Linux kernel? Linus Torvalds. So he's the one who created the Linux operating system and its kernel. Okay, all right, then question number 2, what is kernel in Linux? Once again, a very important question. Sometimes it is like a very basic question, but interviewer can ask you. So a kernel is the main component that makes up a Linux operating system. It is the interface between hardware and software. I'm going to show you a diagram also where I will explain where this kernel lies in an operating system and how does it function. Okay, so just to learn the theory of it first. So it is the main component that makes up a Linux operating system. It is the interface between the hardware and software. The user interaction happens at this level, and this is the first program that loads when the machine starts. So if you have a Linux based machine, generally I'm talking about the virtual machines. Okay, if I talk about in AWS, it's going to be an EC2 instance that has Linux operating system. So the first program that loads, it's going to be kernel. Okay, and then this kernel loads all the other processes. Okay, so as I mentioned, I'm going to explain this with a diagram. So this is how the Linux kernel looks like in an operating system. So suppose you are a user, you are a Linux user, okay, and you want to run some commands. Okay, so what do? You input some commands. So you have a terminal that you see, right? The black colored screen that you see to input commands. So those commands are executed by a program which is part of your operating system. It's called shell. Okay, so there are various types of shell. The most common shell is bash, which is also called born again shell. So when you are actually running the commands from a terminal, you are interacting with this program called shell, and this shell is used to instruct the kernel to do anything. So what happens when you run any command on a shell? The shell is going to process that to the kernel, and then kernel is going to see what the command is and what the user wants, and it's going to interact with the hardware, then process your command or your query, and then give the response back to you on the shell through the terminal. So this is how it works. Okay, so if you see here, this kernel is the interface between the user and your system hardware that actually does the things, right? Hardware, I mean, it is CPU, memory, and your disk storage. Okay, this is because to run any command, or to install any application, to process anything on an operating system, you need the hardware resources, right? So the hardware resources are there, but to interact with it, to use them, you need kernel. Okay, and then this kernel is given instructions via shell when you run the commands onto it. So for example, if you want to install Docker, okay, and here if I take an example of Red Hat Enterprise Linux operating system, so you do yum install Docker, for example. So when you do that, you are just inputting the commands with the help of a terminal. So you use this shell program to process the commands. Okay, so that command is going to go to the terminal, sorry, is going to go to your Linux kernel. Then this kernel is going to see if you have the resources available to install Docker. If yes, it's going to install it, and it's going to instruct back on the shell that this Docker application has been installed, and you get the message that Docker has been successfully installed. Okay, so these are the four layers, you can say, of a Linux operating system on a very high level. Okay, so you have hardware, you have kernel, you have shell, and then you have this application layer where you install all your applications. I hope the concept of kernel is clear. Okay, all right. Then question number 3: why is Linux considered to be more secure as compared to other operating systems? Okay, because we have other options in the market. We have Windows, right? We have some others as well, but I mean, if you see, most of the different organizations, the big enterprises, they use Linux as the operating system to deploy all their enterprise level applications. Okay, so security is one of the things that is taken in consideration. Okay, so since it is open source, we just understood that Linux source code is available to public, so it is open source. So a large number of people are able to examine it and point out vulnerabilities much earlier. Okay, so if you, I mean, give something to 100 people for free to examine, or if you give something only to 10 people, so of course 100 people will be having more information, I mean, they will give you more inputs on something that has been shared with them. So since it is open source, so a lot of different people from different expertise from different domains are are trying to see if there are any vulnerabilities in it, so they are able to report it much earlier. So it is considered to be more secure because the vulnerabilities are reported earlier, and they are remediated as well. Okay, this is one of the reasons that it is more secure than other operating systems like Windows, for example. Then its file and directory permissions ecosystem enables for granular permissions and restrict users to particular tasks only. Okay, so if you know, we can restrict the user to do only a particular task on a particular directory only in a Linux operating system. So its file and directory permission ecosystem is very strong. It's very difficult to break that. So that is another feature of a Linux operating system. So it's very secure in relevance to that. Then when you're creating a Linux virtual machine, you have the option of starting with a bare minimum number of software. Okay, so Linux VM, if you've ever installed it, for example, if you use a virtual machine software like Oracle VirtualBox or VMware, so when you install an operating system, you get the option of choosing the bare minimum first. So it's going to be really small in size as well, and then as per your needs, as per your use case, you can install different software on top of it. Okay, so you have the option of seeing that installation of, I mean, what is, I mean, going into your machine and what is not. Okay, so in that way, again, it is more secure. So you have the option to start with a very minimum number of libraries and softwares for your operating system, and then on top of it, you can install each software one by one, and you can see what all you are installing. Okay, so it again gives you additional insights on what piece of software are you trying to install and from where. So these are 3 points. Of course, I mean, there may be more, but I think these 3 are the very important points in terms of how Linux is more secure as compared to other operating systems. All right, so question number 4: Explain Linux boot process. So once again, it is a very important interview question. It can be asked. So when you start a Linux based machine, what happens? So when you power on the machine, there's a firmware that is on your machine that's called BIOS. It's also called basic input output system. So it is going to perform a hardware test on your machine. That hardware test is called post, power on self test. So it basically means to check all the hardware and validate if hardware is working as expected. If this post test passes, then the same BIOS, which is the firmware, is going to load another component in your system, which is called MBR or master boot record, which is available in the hard disk. So what is MBR? MBR is the information saved in the first sector of a hard disk. Okay, if I talk about hard disk, it may be /dev/HDA or /dev/SDA, depending on what type of hardware you are using. I'm going to show it to you as well on an actual Linux machine, okay, in a while. So this MBR indicates where the bootloader is. Okay, now what is a bootloader? It loads the Linux kernel. Okay, so if I just draw it for you, what an MBR looks like in the hard disk. Okay, so this is clear, I think. So when you start your Linux machine, the first thing that happens is this a firmware called BIOS, basic input output system. It performs the hardware check on your machine. That hardware check is called post or power on self test. The main job of this test is to validate if all the hardware is working as expected or not. If yes, then the same firmware BIOS, it's going to load another component on your machine. It's called MBR or master boot record in the hard disk. Okay, MBR is the information saved in the first sector of a hard disk. Okay, and it indicates where the bootloader is. Okay, so let me just draw this MBR for you. So if I go here, suppose this is your hard disk. Okay, this is your hard disk. So generally a hard disk will be divided into separate blocks of storage like this. So you will have this block level storage. Okay, each block will be again divided into separate different sectors like this. Okay, so for example, this is the first sector, this one. So this will have your MBR information. So this will be the location of your MBR, master boot record here. Okay, so this is how it looks inside your Linux operating system. So this MBR is going to load this bootloader. So right now we have grub2, which is the name of the bootloader. In the earlier Linux operating systems, I believe till if I talk about Red Hat Enterprise Linux version 6, you had grub till then, and from I think grub from Rails 7, I'm not 100% sure, but I'm just trying to recall from my memory. So from Red Hat Enterprise Linux version 7, you are using grub2, which is like an advanced version of grub. Okay, so this bootloader is going to be loaded into your random access memory, into the memory of your operating system, and this grub2 is responsible to load the Linux kernel. Okay, so this grub stands for Grand Unified Bootloader v2. Okay, version 2. So this is going to load the Linux kernel. The location of the Linux kernel is inside your machine will be in /boot/grub2/grub.cfg. Okay, I hope this process is clear to you, how the things are flowing in, how the Linux is booting up from BIOS to MBR to grub2. So then we use this kernel. So after the bootloader is loaded in the RAM, okay, it's going to load the Linux kernel. Okay, so the actual job of kernel when your machine is starting is to load the required drivers, to require all the required drivers from another little file system. It's called initrd.img. So this is the job of kernel. So once grub2 is able to load the Linux kernel, then this kernel is going to load all the required drivers. The drivers are stored in another small file system. You can say it's like a temporary file system. It's called initrd.img. So all the required drivers which are required for your hardware components are loaded from Linux kernel using this init.rd.img. Okay, so and then after the drivers are loaded into your into the kernel, I mean after the drivers are loaded by the kernel for your hardware components from init.rd.img, then it starts the first operating system process. Okay, so in all the modern Linux systems, we are using systemd. Systemd is the first process that loads when your machine starts. Remember this, again, a very important interview question. What is the first process that loads when you start your Linux based machine? So it's going to be systemd, and the process ID that is given to this process is always 1. So this is the first process. So as I mentioned, init.rd is like a temporary file system that is loaded into your RAM so that it can mount the real root file system. Okay, so it is being used by our kernel. Then after the first process starts, which is systemd, it's going to start all the other required processes that are configured in your operating system. So it's going to read the information from another file. So this systemd is going to read another file called /etc/systemd/system/default.target. So this file contains the run level of a machine. Okay, we'll talk about what a run level is. So just understand that after this systemd is loaded, it's going to take your machine to a particular running mode. You can say it's going to take your machine to a particular mode or particular run level. Okay, that run level's location is this one. Okay, to bring the system to the run level, and in total there are 7 run levels in which this systemd can load your machine into. Okay, which we will just talk in the next question. So this is how this Linux boot process works. So please understand this thoroughly. If you have any doubt related to the boot process, please reach out to me. This is a very important interview question. Okay, so just be prepared to face this in the interview. Okay, so this is how the this entire boot process works. Then question number 5 is what are run levels. As I just promised you, I'm going to talk about run levels now. So in Linux, there are different modes in which your operating system can run into initially. Okay, initially means by default. So these run levels have some specific features. Okay, so as I mentioned, there are in total 7 run levels starting from 0. So this is the run level numbers. Okay, and this is how it looks inside the machine, and this is its description. So let's go to let's just see one by one. So run level 0 is to shut down the system. For example, you are logged into a machine and you want to shut down your system, so you can use the run level commands also. Okay, you can use run level commands also to shut down your system. So if your system is shut down, it's called you are in run level 0. It's like that, it's called like this. Okay, so if your Linux operating system is down, is shut down, it's called it is in run level 0, which means you have just powered it off. So shuts down and powers off the system. It's called run level 0. Okay, then run level 1. Run level 1 is also called single user mode or the rescue mode. So if you have some issues with your operating system, you can load your Linux operating system in run level 1 and troubleshoot and perform some maintenance or recovery. Okay, it's called run level 1. Okay, so once again, very important, if you just try to learn these from interview point of view. So there are these 7 levels, and these are their descriptions. Then if I talk about run level 2, which is multi-user mode with networking varies. Okay, so without networking. So run level 1, we see only one user can be logged into the machine at a time. Okay, but in run level 2, you can have multiple users logged in, but there will be no networking enabled on your machine. It's called run level 2. Okay, it's called multi-user.target. So the features, you can say it is multi-user. So I mean multiple users can log in at the same time. but there is no graphical user interface, so there is no GUI on your machine. And this networking can be enabled or cannot be enabled, but generally it is not enabled in run level 2. So that's why it's called multi-user mode without networking. So generally this networking is not enabled. Okay, generally speaking, but as it says, it varies, so it depends, but I'm talking about the default scenario. Okay, then if I talk about run level 3, so this is the one that is there, that we use mostly. So when we are using any Linux operating system for any work, especially if you're working for an enterprise, you are in run level 3 generally, because run level 3 is when multiple users can log into a machine, you have networking enabled, and you only have CLI option available, right? That's what happens. So if you are using your AWS EC2 instance, for example, okay, you are using a Red Hat machine in AWS as an EC2 instance, you are logged into it and you are running some commands. You are working for a company and there are these multiple users who are using the same machine. So that is run level 3, because multiple users are able to log in and there is networking enabled on that machine, and you only have access to CLI, no GUI. So it's called run level 3. This type of mode is called run level 3. So as you can mention, multi-user text mode with networking. So this is the default one, you can say. Most of our Linux machines are using run level 3. Then run level 4 is undefined or user definable. So it is actually like a run level that is open to a lot of customization. Okay, so you can customize it, and you can use it for your own use case. Okay, so if you want to have a custom run level for your company, okay, in that case you can use run level 4. So only in some specific scenarios you are going to use this run level. Then run level 5, it's called a multi-user mode with graphical interface. Multi-user mode with graphical interface. So here you have this multi-user mode enabled, you have GUI also enabled, and networking is also enabled. Okay, so all these things are under run level 5. It's called graphical.target. So multi-user mode with GUI. Then if you want to reboot your system, so when you reboot the system, your system goes into run level 6, which is to reboot the system. That's it. So these are the 7 run levels that you should really know as part of your Linux administration journey. So if I have to check my current run level, so I'm logged into Red Hat Enterprise Linux version 9 machine. It's an AWS EC2 instance. To verify that, you can run the command cat/etc/os-release. So I'm running Red Hat Enterprise Linux version 9.5, also called PLO. So if I have to check the current run level on my machine, I just have to run the command called run level, enter, and you will see the run level. It is run level 3, which is the default one. As I mentioned, run level 3 is the one that we used the most. Okay, so since it's multi-user mode, it's networking enabled, and it is only CLI. So that's what we are on. We are using run level 3. If you have to change it, you can run a command called init. Then if I just hit init like this, it will ask for arguments. So you can do init space the run level that you want to get your machine into. For example, init 6. Init 6 is, if you want to reboot your machine, you can use the run level command also. So you can do init 6. So if I do init 6, enter, it's going to reboot the machine. Okay, so I just got logged out of rebooting after I ran this init 6 command, which means I rebooted the machine. I made my machine go into run level 6. Okay, so if I check on my management console also here, so this machine is just rebooted just now. Okay, it might be still, it might be showing as running because the machine is already rebooted, but this is how you can change the run level as well. Okay, so using this init command you can do so. All right, I hope the concept of run levels is clear to you now. All right, next is question number 6. Difference between sudo su hyphen and sudo su. So sudo su hyphen and sudo su. So this question was asked from me a few years ago in a Linux interview. Okay, I was appearing for a Linux interview some few years ago, and this was the question that was asked by the interviewer. I remember the company was Rackspace at that time. Yeah, Rackspace. So let's log into the machine again and see the difference. Let's just learn about it, and then I'm going to show you a demo. As I mentioned, this video is going to be a hands-on demonstration with all the explanations. Okay, you don't have to go to Google and search for the answers or the explanations. All the things will be available in this one video. Okay, so these 50 questions are going to prepare you really well for your Linux based part of the interview for sure. Okay, so a difference between sudo su hyphen and sudo su. So when you run this command, as you know, this sudo means that you want to run the command as root user. So sudo space su hyphen, when you run it, what happens that you're going to change the username to root, and also the working directory, the present working directory is also going to change to the root user's home directory. So it's going to make you root and change the home directory to the root user's home directory. But if you don't use this hyphen, if you only do sudo su, then it's going to make you root, but it will keep you in the current working directory. Okay, so let's see the demo. I'm logged in as ec2-user. You can run the command id to check. So I'm logged in as ec2-user. Now if I have to become root, so there are two ways by which I can do it. Sudo su hyphen. Okay, one more thing. Let's check the present working directory. It is /home/ec2-user, which is the default home directory for ec2-user. Now if I do sudo space su space hyphen, I became root, and if I do pwd now, you can see my home direct this present working directory also changed from /home/ec2-user to /root because I use hyphen. Now let me just log out, Control D, and this time I'm not going to use dash. I'm only going to use sudo space su. Okay. Okay, one more thing. Let me just show you the present working directory. It is /home/ec2-user. So let's just do sudo space su, enter. As you can see, I became root. I become root, but if I do pwd, I'm still in my same old user's home directory /home/ec2-user. So this is the difference between sudo space su space hyphen and sudo space su. All right. Question number 7. What is shell in Linux? So it is a command line interface that allows user to interact with the operating system. Example, shell. So I think I just explained it in my explanation of Linux kernel. If I go back here, so this is a shell here. So the shell is used to execute commands using a terminal by an end user. Okay, so that's what the definition is. It is a command line interface that allows users to interact with the operating system via the bash program. Okay, so we are using bash shell here. So this bash shell is used to execute the commands that is inputted by the end user on a terminal. Okay, it's called CLI. It's called a shell. It's called a shell. Then what is a file system in Linux? A file system is a way by which you can organize and store files on a disk. So basically, file system, if I talk about whatever hard disk you have attached to your storage, okay, that hard disk can be used to store your data in multiple different structures, you can say. So those different type of structures, keys that you use to store your data, it's called file system. Okay, so file system is a way by which you organize your data in your hard disk. And there are different types of file systems like ext3, ext4, xfs. Okay, to check that, you can run the command. You can run the command df space -h, then capital T. it's going to list all the different partitions, I mean all the different file systems and their mount points where this file system is storing the data. So as you can see, these are the different file systems, and this is the file system type: XFS, VFAT, and then some others as well. But in our case, the most important one is /dev/xvdf4, that is mounted on our root directory. Slash is the root directory. Okay, so it is XFS type of file system. So this is the way you can check the file systems on a Linux operating system, and it's just a way to organize your data in a disk. How do you view the contents of a file page by page? So you can use less command or more command. So if you have to check the contents of a file and you want to scroll through the contents one page at a time, so you can use the less command or more command. So let's just do it. Let me show you. For example, if I do less /etc/passwd, okay, there's only one page of data here, so let's use another one. So log.conf. okay, so this is a file that I want to scroll through one page at a time, so I can use a less command. Okay, so like this. So this is the first page. If you just press spacebar now, it's going to put you to the next page, then again spacebar, then third page, then it's going to show you end, which means the end of the page has come. So this is how you can scroll through the information using less. Similarly, if you do more, again it's going to be page wise. Okay, it's going to show you the percentage also, how much you have covered. So 42% is covered. The next, you have covered 70 to 75% covered on the second page, and if I type spacebar again, it's going to be the last page. Okay, so this is how you can scroll through the information one page at a time using less or more command. Then how can you check the current list of local users on a Linux, on a system? So whatever local users you have created on your machine, okay, whatever are the system users, when you install an operating system, Linux already creates some system users for you for its functioning. So that list of users and whatever users you create manually, whatever local users you create manually, all the users information is stored in this file /etc/passwd. So you can run this cat command to cat the contents of this file to check that. Okay, so this is where the local user information is stored. So these are all the users that are created in the system. So this one line of information represents one user, like this. So there are 1, 2, 3. In this way, there are multiple users created on this machine. Okay, if you want to count that, you can use grep command. You can pipe. Sorry, not the grep command. You can use the pipe command and do wc --l. It's going to count the lines for you as well. So there are 23 number of users. So right now there are 23 users on this Linux operating system or on this Linux machine. Okay, so this is the way you can count the number of lines. Next is, what are file permissions in Linux and what is RWX? So file permissions control who can read, write, or execute a file. Okay, R is representing read permission, W is representing write permission, X is representing execute permission. Okay, so if it is asked in the interview, just explain this to interview that there are three types of permissions available: read, write, and execute. Okay, and once again, I already have one detailed video on file permissions, because file permission is a very big topic and very important one. So I have created one separate video on this already. So go and check that in the same Linux for DevOps learning series playlist. You will find one video where I explain all these permissions in all the detail that is possible, with all the demos that is possible. Okay, to explain you this to the core. Okay, so you can go watch that video. I highly recommend to understand this question number 12 in much more detail, as it is required for you as well. Okay, if you want to work in the Linux domain, if you want to work in the DevOps domain, you need to learn these file permissions to the core. So that video is going to cover everything related to file permissions. But if I have to just show it to you how it looks like in any directory, you can just run this command ls space -al, and it's going to list out the different files and directories available in the present working directory, and it's going to show you the permissions also here. So these are the permissions. RW, okay, so some files and directories will have RW permissions, some will have, so once again, there are different pieces to it. You have the user permissions, you have the group permissions, and you have the other permissions. So depending on what the permissions are on a particular file or directory, you will see these different values. So you will see R, you will see RW, you will see RWX. Okay, this D is representing the directories, which means this is a directory, and this first dash is representing files. So here you can see we have these different files, and we have a directory called this .ssh. Okay, and then these are the permission bits. Okay, so as I mentioned, it is not possible to explain the permissions, read, write, execute in this video because it's a long video, and I've already done a video on this one, so please go and watch that. All right, so question number 13, what is the umask command? So umask command is used to verify what all permissions will be applied by default to any newly created files and directories. Okay, so let me show it to you. So if I do umask, hit enter, I can see it is saying 0022, which means that any new files and directories that I'm going to create as root user here in this directory, it's going to be applied 0022 permissions. Okay, so these are the octal permissions. So as I mentioned, I've already have a detailed video on all the permissions with all the different scenarios and use cases. So please go watch that video, because it's a long video with all the concepts and all the demos as well. So yeah, if you just watch that video, you'll be able to understand all the permissions in Linux. Okay. All right, next question. How to modify attributes of an existing user? Okay, so to modify attributes of an existing user, we can use the command called usermod, which basically means user modification. Okay, so here in this example, what I'm trying to do here is I'm trying to add a supplementary group to a user named Ubuntu. Okay, let me show you a demo how we can modify the attributes of an existing user. So let's create another user first. So let's do user add, and let's type tech applicate. Okay, just any random name. So I'm trying to create a user called tech applicate. Done that. So whenever you create any local user in Linux, okay, a new group is also created with the same name, and the user is associated to that same group, and that same group will be the primary group. In Linux, there are two types of group of any local user. Okay, either it is going to be a primary group, or it is going to be a supplementary group. So this user has its primary group as a tech applicate, but you have the option to add the same user to multiple groups. Okay, you have the option to add this user to multiple groups. Those groups are called supplementary groups. Okay, so remember this concept. Once again, I've already covered this in one of my videos where I spoke about Linux user management, where I've covered all these concepts. But since this question is here, so I just want to give you this information as well, that you create a user, you get a group also created with that same name, and the user is associated with the same group, which is going to be its primary group. But you have the option to modify any attributes of a user. Okay, so let's just see if this user has been created and the entry has been made in the local file where all the user information is available. So let's grep for tech applicate. So I'm trying to grab this username in the file /etc/passwd. So this file stores all the local user information. So whenever you create any user, a new entry is created in this same file. So you can see this user has been created now. Okay. And also, as I mentioned, one group is also created. So you can do grep tech applicate. So whenever a new group is created, an entry is made in another file called /etc/group. So you can see this group is also created here. Okay, it's fine. Now what you want to do, I want to modify the attributes of this user. So I'm going to use user mod, and I'm going to use the same example that is given in the example here in the sheet. So I'm going to do -a capital G. Small a means append, to add. I want to add, then I'm using capital G, which means supplementary groups. I want to add an additional group to a user. Okay, so the name of the group, maybe we can use root group, and the name of the user is tech applicate. So I am trying to add one additional group, one additional supplement group to the user tech applicate. I want to add this user to another group called root group. Okay, so hit enter. Done. Now if I repeat that same command, tech applicate, I can see that this tech applicate is now part of root group also. Okay, as you can see here. So in the first line, it's showing that this user is part of this group, root group, and there's another group called tech applicate. Okay, also if I can switch, I can show you in another way. So let me switch to this user itself. So I'm logged in as a tech applicate now. If I run id command, I will see all the groups associated with this user. So as you can see, UID is tech applicate and GID means group ID, tech applicate, and then you have groups. So groups, you have this tech applicate group, which is the default primary group of the user, but it is also part of another group now, root group. Okay, so this is how you can modify the attributes of a user using user mod command. This is just one example. If you do, let me clear the screen. If you do user mod space help, you can see all the different options that are available with this command. As you can see, you can modify all these attributes of a particular user. Okay, so there are like multiple things that you can do. So please explore this and do a lot of hands-on. All right. Next question: how to copy a directory? Okay, so this is the command. You have to use --r to copy the directory. So let's do that. So what I'm going to do is I'm going to do mkdir to create a directory. Let's create directory 1. Let's just name it as D1. Okay, and then I'm going to create another directory D2. And now if I do ls, I can see the two directories D1 and D2. Now let's try to copy the directory D1 to D2. Okay, so what generally the Linux beginners do, they do cp D1 to D2. This is what they usually do. And then you get this option, omitting directory D1, which means that you are trying to copy a directory. So for directory, you have to use -r. This command works only for files, but not for directories. So what you have to do is cp -r D1 to D2. Now if I do ls, I will see D1, D2, and if I do ls D2, I can see D1 is also there. So what I did, I copied this D1 directory to D2 directory, and when I list the contents of D2, I'm able to see D1. So this is how you have to use it. So use cp -r. Okay, if you had a file, for example, let me create a file also just to show you. F1. If I want to copy the file, I can do F1 to D2. The file will be copied, no error, right? If I do ls D2, now you will see two things. You will see the file that I just copied using this command and the directory that I copied with the earlier command. So just remember, for files, you don't have to specify -r here, but for directory, you have to specify --r. Okay, so question number 16, how do you check open ports? So there are two commands that you can run. Either you can use netstat space hyphen tulnp or ss space hyphen tulnp, depending on what package is installed on your machine. Okay, so this is again a very important question. Okay, how to check the ports which are open on your Linux machine. So let's go here, let me show you. So you can do netstat hyphen tulnp, and it's going to show all the ports that are currently open on your port and your machine is listening to them. Okay, if you don't get this command working, you can check if you have this net hyphen tools tool is installed or not. So you can do yum install. If you're using a Red Hat or Fedora based or CentOS operating system, you can use yum install net hyphen tools to check to install this package which has this command netstat hyphen space hyphen tulnp. Okay, so if I run it right now, it will say the package is already installed. Okay, the other command was ss space hyphen tulnp. It's going to show a similar type of result. So there are two ways by which you can check the open ports on Linux machine. Okay, now if I just want to show you these flags that I've used with the command, what does it actually mean? So let me clear the screen. You can do man netstat to check the manual of this command. Okay, netstat, I'm using man command, man space netstat, and you can see the different options. So T stands for TCP, U stands for UDP, then L stands for listening, N stands for numeric numbers, numeric information, okay, which we wanted to see the port numbers, and P stands for program. Okay, what all these programs are associated with those ports. Okay, so this netstat hyphen tulnp and ss space hyphen tulnp. All right, next is which directory stores all the log files on a system. So it's always /var/log by default, where you will find all the different log files for different applications and processes that are running on your Linux machine. So you can go to /var/log and you can do ls space hyphen al, and you can see all the different log files available. Okay, so depending on what application you are searching for, you can check it in this directory /var/log. It's the default log directory in Linux. Question number 18. What is the difference between SU and SUDO? So SU is switch user. It is to switch to another user. If you want to log in with another user, you can use SU command. And SUDO, also called sudo or sudo, it's execute a command as root user. Okay. So here, if I just show you the example, I'm logged in as root user, and if I want to switch with another user, I have a user called techapplicate. So I can do su hyphen techapplicate space hyphen, and I will be logged in as techapplicate. Okay, and if I want to run a command using sudo, so this user is not a sudo user, so I will not be able to run the command using sudo, but what I can do is I can log out and I can log in as ec2-user. So ec2-user is the default sudo user on this Linux machine. Okay, so su is used to switch a user. So here I was logged in as root user. Now I switch to techapplicate. Now I want to check for sudo command. So for example, if I install anything, let me do yum install crony d. Not root subscription manager repository is not updated. This command has to be run with superuser privileges. So if you see, I tried to install this package called crony using yum command, but since this user is a sudo user and it did not apply the sudo command. Okay, so either I should be logged in as root user or I should be using sudo with the root, with the sudo users. So I'll get this message. Okay, not root. Sorry, not this one. This is the error. This command has to be run with super user privileges under the root user on most systems. So if I repeat the same command with sudo, so this time if you see, no match for argument cronid. Okay, which means that this package name is not available on the machine, but I did not receive any permissions error. Okay, like the previous one. So this command actually worked, but the name of the package was wrong. So I got this message: no match for argument cronid, unable to find a match cronid. Okay, so the command ran, but of course the package wasn't there. So let me try to install something else. Let me install Nginx, for example, the famous web server. So if I do yum install Nginx, yep, if you see, I get the prompt. If I do yes, I will be able to install it. So I did not receive any permissions error. All right, Nginx is installed. So the command worked. So this is the difference between sudo and su. Question number 19. How do you undo a yum install on Rail or CentOS? Okay. So there are so this is one of the ways. So you can do yum history. It's going to provide you with the list of all the commands that you run using yum command. And then you can, if you want to undo something, if you want to, if you have installed a package on a machine and you want to uninstall it, undo it. So you can do yum history undo and the loaded ID. When you do this yum history command, you get the history of all the commands with a loaded ID attached to it. So just have to specify that command and run this yum history undo command. It's going to uninstall that package. We can see that we just installed this Nginx package. If I do yum history, I can see the ID is 5 for install Nginx. So if I have to undo this, I will do yum history undo, and I have to supply the ID, which is 5. Of course, I'm going to get this message because again, to uninstall this package, I need to be root. So I'll repeat the command and add sudo to it. And it's going to give me the message that it's going to free up 1.7 MB of space and you are removing this package and its dependent package as well. Okay, so I will do, if I do yes, the package is removed. Okay, so this is how you can undo a yum command, yum install command. Okay, so question number 20, what are some system performance monitoring commands? So of course, as a Linux administrator or any administrative role that you are in, you need to monitor the performance of your system from time to time, especially when there is some issue, when there is some errors related to any application or anyone has reported anything. In that case, you need to see what all is happening in your system. So you have to check a lot of different performance metrics, you can say. So you have a lot of commands, like I've just mentioned a few of from the entire list that is there. So these are some of the most commonly used system performance monitoring commands. Okay, so of course this can be asked in an interview as well. So let's see. So here I am, and let's see. Okay, top or htop you can use. So let's use the top command here. So top command is going to give you a lot of information around your CPU utilization, your memory utilization, your load average, okay, and how much CPU is being used or it is idle. In terms of memory also, you can see a lot of information. If you want to sort this information, for example, I want to see what all processes are consuming the highest CPU on my machine, so I can just do shift P. So after running the command, just type shift P from the keyboard and it's going to sort everything CPU wise. But yes, I don't have any process that is taking a lot of CPU here, so I'm just seeing this one process consuming 0.3. Okay, so this is how you can sort your results by CPU, and if you want to sort it out with memory, just type Shift M, and it's going to sort the processes memory wise. So whatever process is consuming the highest memory, highest RAM, it's going to be there on the top. Okay, so similarly there are other variations as well. You can check, you can verify. So to come out of it, just type Q, and you can do man top, and there are different combinations of commands or the things that you can do with this page. As you can see, it's a long list of things that you can do, okay, depending on what do you want to achieve. Okay, so this is one of the most used system performance monitoring commands, top command. Okay, similarly, if I show you some other commands, let's go for vmstat. That's going to show the memory statistics. So let's do vmstat, and you can see some information related to your memory and your CPU as well. Okay, so once again, you can do man vmstat to understand all the different things that you can do with this command. Okay, next is free-m. It's going to show the free memory. Free-m is going to show the buffer memory, the free memory, or the currently used memory and total memory available on your machine. Okay, in MBs. M means it is in megabytes. All right, next is you can see iostat. So if you don't see this package, if you don't see this command running, you can install the package systat. Okay, so iostat, it's input output. Iostat is in input output statistics. Iostat, and you can see some information related to your CPU, how much CPU is used, how much is idle right now. It's 94.1% is idle, so it's looking very healthy. The device information in terms of reads per second, writes per second, and some other details as well. Okay, so all this is available in iostat, input output statistics. Similarly, you have netstat, which I already showed you, but let's just see again. Netstat, it's going to show all the information related to different processes. Okay, like this. Then you also have SAR command, system activity report. Okay, once again, if you don't see this installed, you can install the package systat. So if I do systat, sorry, not systat, SAR. Okay, so this is like you run the command without any options, but generally you would use it like this. So I have given two examples here. First, if one is for CPU, the other one is for RAM. So if I run this command, this one, so what it's going to do, it's going to give me the report of my CPU in every 2 seconds of interval 6 times. So it's going to show the report of the CPU usage at an interval of 6 times, like this. Okay, so it was idle, it was at 95.67% idle at this time, at this time, at this time, like that. Similarly, the other command is for RAM. So if you want to check your memory status every 2 seconds 5 times. So this is a system activity report. Like this. Okay, and once again, you can do man SAR, and there is a long list of different flags that you can use with this. Okay, depending on what you want to achieve. And one more thing you have to check is for SAR especially, if you see some errors or if it says something not configured, so there's a configuration file for SAR that you have to verify, which is this one, vm/etc/default/systat. So just open it, and you should have this enabled is equal to true. Okay, if it's not there, just write it manually, enabled is equal to true, and restart the systat service. Restart the systat service also to apply the changes. If you see any issues related to running this command, SAR command, after making the changes, just restart this service, systemctl restart systat service, systat.service. All right, these are some of the performance monitoring commands. So question number 21, how to investigate and troubleshoot an issue if the system is very slow. One of the most common interview questions, and also when you're working real time, these are the type of issues that you will be facing, and you should know how to identify, troubleshoot, and resolve these type of issues. So if your system is working slow, it indicates that there's a process or a list of processes that are consuming a lot of resources on the machine than what they should actually do. So you have to identify those processes and see if you can kill those. Okay, if it is in production, of course you have to take approval. So if it is going to impact anything, you have to take the approval of the application owner generally. Okay, and then try to kill the process and see if it helps to improve the performance of your system. Okay, in the lower environments, you may go ahead and do it yourself. Okay, but it depends from organization to organization, one project to the other. Okay, anyways, so let's see it in action. So as I mentioned, it indicates that some resources are consuming, some processes are consuming a lot of resources on the system. You have to identify that. The most common command that we use is the top command, and then we can just kill it. So there are two ways to kill it. Either we can use kill space the process ID, or we can use kill space -9 process ID. So -9 is actually like you are trying to kill the process forcefully. Okay, and this kill PID is generally means you're trying to kill the process gracefully. So we try to use this kill command without -9 first. If it doesn't work, so then we go for kill space -9. So to simulate this this scenario, I have this command called dd command. It's going to simulate the increased CPU utilization on your machine. So you can copy and paste this command here and just use the add symbol so that it runs in the background. Okay, so I just ran this command, and now let's see what process is consuming a lot of resources on my machine. So you can do this top command, and you can see at the top this dd command is consuming like 99% of CPU. Okay, so suppose this process is making your system go slow, and you have all the approvals. Now you want to kill it. So what you can do is you just have to see its process ID, which is 3315. So just come out of it and do kill space 3315. Once done, then you can check the top command again, and you can see the process has been killed and your CPU utilization is back to normal. Okay, here you can verify that. In the above screenshot, you can see your CPU utilization, it's increasing. Okay, and if I check the other screenshot, you can see it has improved. Okay, so this is how you can kill the process. Okay, but as I mentioned, if it doesn't get killed, then you can do kill space -9 also. So it can be kill space -9. Okay, I already have one video where I have covered all these different signals that we do, that we redirect to the different processes and in what scenarios. So please do watch that video to understand all these signals in a lot of detail. Okay, this is done. So question number 22, how do you schedule a script to run automatically at 11 PM every day? In Linux, if you want to schedule any script to run automatically at a particular time of the day, you can use the concept of cron jobs. I already have one video where I have covered all the concepts and demos to illustrate this utility in Linux. So you can go watch that for all the details. Okay, in this video, I'm going to show you an example how to schedule this cron job. Okay, so here it is saying that we have to schedule it to run at 11 PM every day. So to do that, you can use this command called cron tab space -e. So it's going to be cron tab space -e, and then you can specify the schedule on which you want to run this script plus the path to your script that you want to run. Okay, so here I have given the example here like this. You can copy this and paste it, and then you can go through this table here which shows what these different fields mean. So in our case we want it to run at 11 p.m. Okay, so this is going to give me the minute at which I want to run, which is 0. This 23 is representing the hour. Okay, so it means 11 p.m. Then you have the day of the month, which is the third field. Okay, I'm using star, which means every day of the month. I'm also using star in the next field as well, which means every month of the year. Okay, and then the last one is the day of the week. This last star is for day of the week. So which means that this command is going to run 11 p.m. on each day of the month, each month, and each day of the week, which means every day. Okay, so this is what the question was. We want to try to schedule this job at 11 p.m. to run every day. So this is how you can schedule it, and this is what this entire, these different fields, these 5 fields are representing these minutes, hours, day of the month, month of the year, and day of the week. And this is how you can use the different values for. Okay, and you can just go through this to understand. And if you need more details around the concepts, you can watch my earlier video in the series. Okay, so let's just complete this. So the path is going to be, let me do /root /path.sh. Okay, so this is the path in which my script is placed in. So I'll save and quit. Okay, so if I do ls, I don't have any script, so let's just create a script. Okay, script.sh. Okay, I think it's something else. Let me see. Okay, yeah, let's just remove this. This is from some other video that I was doing, so let's just delete this one. And let's try to create the path.script. Okay, because our script is path.sh. Okay, so let's try to create that. So what I'll do is, let's echo something like I'll just create this file. So what I'll do, I'll create a new file called path.sh. It's going to be a shell script, so I can use bin/bash, and I can do like echo cron job and just save and quit. Okay, so this is a simple script which is going to echo this text called cron job, and it's going to run at 11 p.m. every day. Okay, so this is how you can configure. Okay, so if you do pwd, you can see the path is /root/path.sh. The path.sh file is available. Also make it executable, so you can do u+x. Okay, so the script is there and it has become executable, and it has been configured in cron tab. So this is how you can configure a cron job in Linux. Okay, in the most basic way. All right, I hope this is clear to you. All right, so question number 23, how to check if a remote server is reachable or not. So let me give you a real-time scenario that happens. So if you are working in an organization and suddenly a user reports that he or she is not able to access a server, so the request is going to come to you if you are the administrator of that server. So the first thing that you do, you just see if the server is reachable or not. Okay, so what you do, you can use the ping command. So ping command is one of the most common commands that we use to check this server reachability. Okay, so it's pretty simple. If you are using a host name, you can use ping space server hostname, or if you have a server IP, you can use ping space server IP. Also, you can use this command called telnet. So telnet's server name, then the port on which you want to test the reachability. Then of course, if you have an IP, you can use the IP as well. So let's see it in action. So let's go to my AWS management console, and here you can see I have two machines here, and I'm logged into one of the machines, which is 208 IP. If I go back, 208 is this one, I believe. Yes. So I'm logged into this demo-ec2, and if I have to test from this machine whether this other machine, which is Docker Ubuntu 24.04, is reachable or not, so I can do so. So I just need to copy the IP address. So once again, it depends on what is the connectivity configuration, okay, in your organization for a particular server to reach to any other server. Okay, so here I'm logged in from my laptop, and these two servers are in public subnet, so I can use their public IPs to test. Okay, so I'm copying this public IP of the other machine. Sorry, I need to copy the other one, so let's copy this one, and I need to go here and use the command ping, and you can see I'm able to reach this server. Okay, so this is working fine. Okay, it's going to go on and on, so just type Control-C. If you want to perform this test for a particular count, you can do so by using -c and then the number that you want to specify. So it's going to perform the test only 4 times, and you will get your prompt back. This is the most famous way, or you can say the most common way. So if interviewer asks you how to check the reachability of a server, you can just tell them that we can use the ping command, ping and then IP address. Okay, so this is the most basic way. Then other command that you can use is telnet command. Okay, so for telnet, just ensure that this telnet package is installed. If not, you can run the command yum install telnet -y. Okay, if you don't have a telnet installed. So to test the connectivity using telnet, you have to use a telnet command, then the IP address and the port on which you want to test the connectivity. For example, I want to test the connectivity on port 22. So it will give you the message connected to this, which means that this port on this IP is reachable from this server. Okay. Fine. Then question number 24. A user cannot access a file. How would you check and fix the permissions? Here I've mentioned use ls space -l to check permissions, and then chmod to modify the permissions. So let's see a scenario on my machine. So I'm logged in as a user John. As you can see, I'm logged in as user John, and if I do ls space -l, I can see all these different files available. So suppose I want to access this file. It's a script file. So if I do cat, you will see I'll get the message permission denied. Why? Because this user John is not part of this group called root. So this here is representing group permissions of this file. So if I do ID here, you can check that. So user John is only part of John group, which is the default primary group that was created at the time of creation of this user John. So user John is not part of the root group, so he does not have access to the group permissions. Okay, because in group you have the read permissions to see the contents of the file. Okay, but since this user John is not part of the root group, he is not able to access the file. Also, if you see the user ownership of this file is with the root user. Okay, so it is not John. Also, if you check the other permissions, in other permissions, there are no permissions at all, which means that apart from root user and the users who are part of the root group, only those people can access this file as of now. Okay, okay, else no one else can access the file. I hope this is clear to you. Okay, this is again a very important concept in terms of Linux permissions. Okay, if you have any doubt related to this, you can go and watch my video on Linux permissions, where I've explained these things in a lot of detail. Anyways, so right now what we have to do is we have to change the permission. To change the permission of a file, we can use the chmod command. Okay, so if you see here, this file has root permissions. Okay, so what I'll do is I'll log in as root user. I'm logged in as root now, and I will modify the permission. So what I'll do is chmod, I'll do O plus R. O plus R means I'm applying read permissions to other permissions on the file. Okay, I'm just adding this read permission on the other permissions of the file, this one. So these 3 bits are representing the other permissions, other user permissions. So I just want this to be have read access to John user. Okay, so if I just apply this permission O plus R to this file, then John will be able to read the content, because I wanted to read the content of the file using this cat command. Done. Now I will again log in as John. Okay, now I will check the permission. So now if you see, this part.sh has read permissions, which wasn't there earlier on the other permissions. Okay, so which means that anyone other than root user and the users who are part of the root group, other users can also at least read the file. Okay, they will not be able to do anything else. They will not be able to change anything within the file, but they can read the content of the file, because I just applied the read permissions, okay, to this file. So now if I run that same command, you can see I'm able to get the contents of the file. So this is how the permissions work, and this is how granular the permission can be, and that's why it is one of the most secure operating systems around. Okay, so you can control the permissions on a very low level in Linux, as you can see here. Okay, so I'm able to cat the contents now after I applied this read permission. Fine, I gave you the example, but once again, if you watch my video, I have I have multiple scenarios like these to give you a clear understanding of all the concepts related to Linux permissions. All right, this is fine. Then question number 26, how would you troubleshoot low disk space issue on a system? So it says run df space -h to find out how much space is left. Then you can run du space -sh star, then pipe it with sort command, and then you can use head to find out the top 10 results. To find the larger files, you can delete or archive. Okay, so once again, if you have space issue on a machine, so there are multiple ways that you can troubleshoot the issue. Either you can increase the size of the disk as well. Okay, that's also there. So you can increase the size of the disk to include to have more storage on the machine. This is one of the ways. Or if you think that there are some files which are not required anymore, but still occupying some storage on your machine, then you can delete the files or you can archive the files. It's up to you. It depends on what files you want to take action on. Okay, so here the first thing is you have to check the space. For that you have to run df space -h. So let's go here and let me log in with the root user, clear the screen, and I'll do df space -h. So I can see right now that 85% of my root volume has been utilized, has been occupied, and only 2 GB is left. So 12 GB is occupied. Okay, now the first thing that I will try to do, or it is actually the best practice, okay, not to add storage straight away. Just see if you can delete some files or you can archive some files, because adding additional storage is going to increase your AWS bill as well. So this is an AWS EC2 instance. So the best approach is to just see if you can delete some files that are not required. So whoever accesses this machine, you can check with those people. With all the users, you can send an email to check with them if there are some files that are there in their home directories which they're not using, because this machine is going to get full on storage soon. So this is what we do in real world. Okay, but in my case, what I'll do, suppose I know that there's a user who does some work and he has some files that I can at least archive. Okay, or maybe I can delete if I get the approval from him. So in that case, what you can do is you can run the command. You can run this command to identify the files. Okay, I'll explain this command as well, how it works. So first thing is, so I know, as I mentioned, that there's a user that I know who does some work, and he sometimes creates big files which he may not be using right now. So for example, that user is John, for example. Okay, so what I'll do is I'll go to his home directory. So I'm logged in as root because I'm the system administrator. Okay, so I'll go to his home directory first, and then I will run this command. Okay, now let me explain this command, what it's trying to do. So DU stands for disk usage. So what it's trying to do is it's trying to calculate the disk usage of all the files and directories in the current directory. Okay, here I did not specify any path. I just mentioned star, which means it's a wildcard, which means all. Okay, so I want to check the disk usage of all the files and directories in the current directory, and then I want to sort it, okay, in a way where I can get the file or the directory with highest space on the top, and I want only the first 10 results. When you use this head command, it's going to ensure that you only get the first 10 results. Okay, so let's try to run this command and see the output. As you can see, I just got 10 results here. Okay, and here I'm seeing this file 1 which is there, which is occupying 10 GB of space. Okay, and this is the culprit file, you can say, which is occupying most of the space on this machine. Okay, as you can see, it's uses this 12 GB of space has been used, from which 10 GB is with only one file. Okay, and this is the user's home directory. Okay, John's home directory. So what you can do in this case is you can reach out to John to confirm with him if he needs this file. If yes, then he can maybe copy it on some other server on his local laptop. Okay, if possible. If not, then you will ask, you will request the approval either to delete it or to archive it. So for example, he says, okay, I don't want this file, you can get rid of it. So as an administrator, I will do rm -rf file1. Done. Now if I do df -h, I can see the space has been cleared. So only 13% of space is used, and earlier on it was 85%. Now it is back to 13%. So my system is healthy in terms of storage space. Okay, so this is how you can see the issues in real world, and this is how you approach this type of issue. I hope the concept is clear to you. So question number 27 is how to grant sudo access to a user. So there are a couple of ways that I know of. First one is by adding the user to a file called /etc/sudoers. Okay, one more thing, sudo access is given to a user so that he or she can run root level commands. Okay, root level commands without actually becoming root. So that is where we use this sudo access to a user. Okay, so you can add the user to a file called /etc/sudoers, or you can add the user to a group called wheel group. Okay, and again you have to modify the attributes of the user using the user mod command, and you can add the user to the wheel group. So there are a couple of ways that by which you can do it. Okay, so let's see a demo of it. So let me switch to John user that I have on my machine. So let's try to install a package and see if John can actually run root level commands or not. Okay, of course he cannot run the command because he's logged in as John, and he is not using sudo also. So first let's try with sudo. So let's add sudo in front of this command and run the command again, and this is what we will see if the user is not part of the sudo group. So John is not in the sudoers file, this incident will be reported. So this is the error that you get when the user is not a sudo user and you're trying to run sudo commands for from that user. So to fix this, you can make an entry to sudoers file as I mentioned. So let me log in with root user. So there are a couple of ways by which you can add the user into sudoers file. Either you can run the command called visudo, or you can manually open the file as well. Both are same. So visudo is like a shortcut to this. Okay, so you can either run this or you can run this command to add the user to sudoers file. So let me use the shortcut, which is visudo, enter, and here as you can see, let me set the line numbers. So this is line number 100 here. So just below this, you have to make an entry for the user that you want to add to this file. So just type John, and then if you see the space between root and all, this is tab space. Okay, so use tab once and then just copy and paste this like this. Save and quit. Now again switch to John user and try to run the same command again, and this time it's going to work. Okay, you get the option to install. Okay, if you do Y, it's going to install the Nginx package as sudo. This is how you can do it. Okay, other way is, so let me just delete the entry first. So this time I'm going to use the other way, /etc/sudoers. So I'm trying to remove the entry from sudoers file, and then we will see the other way to add the user, or to make the user a sudo user. Okay, so I'll go to line 100 again. And I'm going to delete the entry. Save and quit, done. Now let's test it. It shouldn't work. Let me delete the package first. So I'll do yum remove nginx. Package is removed. Now I'll switch to John and try to install the package again. And this time again, John is not in the sudoers file. This incident will be reported. So John has been removed from sudoers file, so he does not have any sudo rights. Okay, so now the other method is you can add the user to a group called wheel group. Okay, so this is the group which will give you the root permissions. Okay, so for that, do user mod space -a capital G. Name of the group is wheel, and name of the user is John. Done. Now again, let's switch to John and try to run the command again, and you will be able to run the command and install the package. All right, this is how you can add the user to sudo. You can make a user a sudo user. I hope the concept is clear. I've shown you both the ways. Then how to delete files and directories. It's pretty simple, but sometimes people are not sure how to delete a directory. In particular, I've seen that. So let's do ls here and see what all files are available. Let's use ll command. So here you can see I have these different files available in this directory. So to delete a file, it's pretty simple. Just run rm file name. So I deleted F2. Now if I do ll, I won't see F2 file. Okay, it's gone. So it has been deleted. That's fine. Let's try to create a directory here with d1 ll. You can see the directory d1 is available here. And to delete a directory, if you do just rm directory name, it won't work. Cannot remove d1. It's a directory. Okay, so you have to use rm space -r d1 to remove the directory. Okay, if we do ll now, directory is gone. I hope the concept is clear. So to remove a directory, you have to specify space -r flag as well. Next, what is chmod 755 permission? So see, this again is related to permission. Okay, so let me just give you an idea. Chmod 755. Chmod 755. So 7. Let me come out of it. So read, write, execute. So this is how you use the octal permissions in Linux. Okay, so read is represented by number 4, write is represented by number 2, and execute by number 1. Okay, this first bit is for the user permissions. If you see here in this result, the first 3 permissions are user bits. Okay, so this 7 means 4 plus 2 plus 1, 4, 5, 6 and 7, which means that these particular permissions are on. Okay, which means that, so I'll take the example of this file only, part.sh. If it has rwx, okay, rwx means it has all the permissions. It means it has this permission number 4 also, this has permission number 2 also, this has permission number 1 also. So if you add these, okay, together, then it is called permission 7. Okay, this is the user permission. Similarly, the next 3 bits after this rwx, the next 3 bits are r dash dash. Here if you see, only r is there and the other 2 permissions are dash dash, which means the group permissions and other permissions are null or nil. So and r is represented by 4. So it has 4 permissions. So all I'm saying is this file currently has the permissions as 740. Sorry, 744, which means that the users have all the permissions rwx. The group has only 4 permissions because there's only read permission. So read is represented by number 4. Read is represented by number 4. So number 4 is here. Then other permission also, only r is there, which means only number 4. So 744 is the current permission of this file. So if I have to check for 755, it simply means that the user has all the permission, read, write, execute 7. Then the meaning of this 5 is 4 plus 1. So which means that only read permissions and execute permissions are there on group. And similarly for other permission also, it is 5, which means read plus execute permission is there on group. So this is the meaning of this chmod 755 permissions. Chmod 755. Okay, so this is how the permissions are written in octal notation, you can say, octal notation. Okay, so both these things are same. Either you can specify the permissions like this, where you specify this rwx, or you can specify the permissions like this also. It's the same thing. So this first bit is representing the user permissions, the first 3 bits like this. The second bit is representing the next 3 bits, which is r dash dash, and the last one is the other permissions, which is represented by the last bit here, and here it will be r dash dash. It's the same thing. Okay, so either you can specify the permission like this, or you can specify the permissions in the octal notation like this. I hope the concept is clear. Once again, I've already have a video on this, where I've explained everything there as well. Okay. Next is how to move or rename files. So let us see what all files are there. So I have all these files here. If I have to, and also let me create a directory here, D1. Now, if I have to move a file, okay, so for moving and renaming, the command is same, mv. It just depends in what context, in what scenario you are using. Okay, so it's going to either rename the file or it's going to move the file. Okay, so let's see both the scenarios here. Suppose I want to move a file called f9. So I can do move f9. Then where I want to move this file to this D1 directory which I just created. Now if I do ll again, sorry, then I won't see this f9 file. F9 is not available here because f9 has been moved to D1 directory. If I do ll on D1, I can see this f9 file is available in D1 directory. So this is the way to move the file. If you have to rename the file, then it means you want to keep the file in the same directory, right? So for example, I want to rename the file called f8 to rename. For example, I am renaming the file as renamed. If I do ll now, I can see the file which was f8, which is not available now because that file has been changed to the name renamed. So you see how you use it. So when you use to rename it, you can use it. I mean, it's going to work for both renaming and moving the file. It just depends where you want to, in what context you want to use it. Okay, so either you can, use it like this in the first example, or you can just use it to rename a file like this. Okay, remember this. So question number 31 is, what is Z command? Give an example. So Z command is used to replace some text in the file. Okay, so let me give you the example. So I have a test file already created. So this test file has some random text like this is an apple, this is a ball, this is a cat. So now, for example, I want to replace this with that throughout the file. Okay, so one way is to do it manually, like I can change manually. So all the occurrences of this can be changed to that. Okay, the other way, or the better way to do it, is using Z command to replace the text. So what we can do is we can run this command Z space -I. Then we can specify substitution / old text, which is this. I want to replace it with new text, that is add that, and I want to do it globally, which means I want to replace the text in all the occurrences in a file. Okay, which file? Then specify the path to the file. In our case, it's going to be test file. Now if I see the file, then this will be replaced with that. So this has been replaced with that. Okay, so this is how you can use Z command. Very useful command again. I hope the concept is clear. It's pretty simple. Next is question number 32. Where is local user password stored in Linux? Okay, so all the local users password are stored in /etc/shadow file. Very important question from interview point of view. So if you do cat /etc/shadow, okay, I'm logged in as root user, so let me become, sorry, I'm logged in as John user, so let me become root and run this command again. So you can see this this part here. So if you see, this is the password bit, but this password is in encrypted form. You will not be able to see the password. Okay, so the file is /etc/shadow, where all the local users passwords are stored, but in an encrypted form. It cannot be seen straight away by accessing the file. Okay, but just remember the file location at /etc/shadow. Next, how to lock and unlock a user account. It's pretty simple. For example, I want to lock a user, so I'll do user mod, then capital L for locking, and then the name of the user, John. John is locked. Now let's see if I'm able to switch to as John user. Okay, I'm logged in as root, so I think that is why I'm able to switch to John. If I am logged in as EC2-user, for example, and then if I try to switch as John, I won't be able to. Okay, authentication failure, because user John is in locked status. Okay, user John is in locked status, but so it will not work. So I will not be able to switch to John unless I'm root. So as root you can still switch, but as any other user you won't be able to switch to that user until he or she is unlocked. Okay, so let's become root. And then unlock the user using -U, which is to unlock the user, then name of the user. Done. Now I'll become EC2-user again, and now I will try to switch to John after unlocking him. And you can see I'm able to log in with John user now after I unlocked him. So this is the way by which you can lock and unlock a user on a Linux machine. All right. Then question number 34, what is a sticky bit in Linux? So with this bit set, the users can only delete files or directories that they own. Okay. So let's see it with an example. Okay. So next is another type of permissions which is applied on other bits. So if you see the sequence, the SUID is applied on user permissions, the SGID is applied on group permissions, and then this third type of special permissions called sticky bit is applied on others permission. Okay. So what is a sticky bit? With this set, the users can only delete files or directories they own. Okay. So we'll see a real example to understand this. So, but just remember that when you set sticky bit on a directory, then what's going to happen? The users can only delete the files or directories within that directory which they own. Okay, so so once again, there's a use case where we use this sticky bit. The use case is we have two developers named dev1 and dev2, which are part of the same dev team. They both share a directory called /share2 on a rail system, and we have to find a way to restrict each of them to not able to delete files under /share2 directory which they do not own. So once again, there is a so for example, there's a project going on, and this dev team has a shared directory on a server, and all the team members have to work on this project. So but we have to ensure that the files created by one team member cannot be deleted by another team member. Okay, so in that case we can use the concept of sticky bit. So once we set this bit, the users will only be able to delete the files or directories within that directory which they own. Okay, so no matter how many users are using that directory, the files can be saved. Okay, so sometimes it is called I mean, we're trying to restrict the deletion of the files, okay, using sticky bits, using the sticky bit set on a directory. Okay, so how to set the sticky bit? Chmod, then others +t. Okay, O +t on the directory where you want to set the sticky bit. Then if you want to remove it, just you replace the plus with minus. So o minus t slash share 2. Okay, so now once again we are going to see an example. So I'm going to log in as root for this example. So let's clear the screen. Let's become root sudo space su space hyphen. Logged in as root now. I'm going to create one more directory, mkdir space slash shared 2 as given in the example. I'm going to check the current permissions of this directory slash shared 2. So this is the current permissions of slash shared 2 directory. Then what I'm going to do is I'm going to, okay, so now I'm going to set the right permissions on group. Okay, why I'm trying to do that? Okay, because I want these two developers to be able to create the files within this directory. Okay, so anyone who wants to create the file, okay, should be part of the group, because this directory can be owned only by one user. But if you want to have multiple users, okay, trying to create files within a directory, those users should be part of the same group. Okay, so and once they are part of the same group, they should also have the right permissions within the directory to create any new files. Okay, so that is why we are trying to add this right permissions. So I'll use this command chmod g plus w, then the name of the directory. Okay, share 2. Now if I check the permissions again, I can check I have this right permissions for the group as well. All right, now what I'll do is I'm going to change the group of this directory to dev. If you see right now, this group is being owned by root. So I'm going to change this group from root to dev. Okay, for that what I have to do, I can directly use this chgrp command, which we spoke about in our last session, in our last video, part 3. So chgrp space name of the group, which is dev, space name of the name of the directory where you want to change the group to dev, shared 2. Okay, chgrp dev slash shared 2. Now if I check the permissions again, I can see the group has been changed from root to dev. Okay, next okay, chgrp dev. Okay, I think this command should have come a little bit earlier. So what I'm trying to do is I'm trying to add this group now. I think this group is already there, maybe not, let's see. So I'm trying to create this group add dev. Yeah, the group is already there, and that is why I was able to change the permissions to dev. Okay, so just ensure that you have this group already created. So let me just cut this command from here and put it here after this. So create this group in advance. So I mean, before you run this chgrp command, you should have this group already created. Okay, all right, so the group was created, and I have changed the group permission of slash share 2 from root to dev. Next, I'm going to create 2 more users. Okay, the users that we took the example of, the example dev1 and dev2. So now I'm going to create these 2 users. So I'll do user add, our old command, to create any new user. And what I'm going to do is, while creating these new users, I'm going to change their primary group, which is represented by small g. not capital G. Okay, remember this capital G is for supplementary groups. The small g is for the user's primary group. Okay, so I'm trying to modify the group while I create it. Okay, I have the option. Remember from our past sessions that we can change. I mean, we can customize the details of the user while we are trying to create the user. Okay, so I'm trying to create a user with the group as dev dev1. So the meaning of this is this new user dev1 will have its primary group set to dev instead of dev1, which is the default behavior. So I'm trying to change the default behavior of this command. Right, so I hit enter. I'll reuse the command and I'll change dev1 to dev2. So I have two users now with dev group assigned. Okay, I can check, I can verify, I know. So a dev1 user has his primary group as dev. Similarly for dev2 also, you will see the primary group of dev2 user is also dev. Okay, now I'm going to set the password for both the users. passwd dev1. Similarly, I'll change the password for dev2. Password changed. Next, I'm going to switch to this new user now. su space hyphen dev1. Sorry. So I'm switched as a dev1 user now. Now I'll try to create one file using touch command under /shared directory /shared/dev1. So remember, I created one directory called /shared2. I changed the group of the directory to dev, and then I created two users who are part of the same dev group. So that is why I'm able to create this file under /shared2 directory. Also, if you remember, I also assigned write permissions to the group. Okay, that is because I wanted these users to create files under this directory. So they should have write permissions. Only then they can create any new files in that directory. Okay. So I'm logged in as this dev1 user, and I'm trying to create one file called dev1 under /shared2 directory. Done. Now I'm going to switch to dev2 user. Dev2, enter the password. So now I'm logged in as dev2 user. Okay. Now I'll try to remove the file created by dev1 user in /shared2 directory. Okay, so you will be warned that you're trying to delete this file, which is empty. Remove write protected regular empty file. I'll press Y and enter. And now if I check the files within /shared2 directory, I can see the file is gone. Okay, which means that right now for /shared2 directory, even though the file was created by dev1 user, the dev2 can delete the files created by any other user. Okay, we just check the demo, and now we want to stop this. Okay, that is why we want to use sticky bit here. Okay, it's a shared directory, but we don't want any user to be able to delete files created by any other user in that shared directory. So this is what we want to stop, and we can use sticky bit for it. Let's see it in action, how we can use sticky bit. This is done up till until here. Now I'll become root again, so I'll type Control D. Okay, once again I'll use Control D, and I'm going to become root now. Okay, next I'm going to apply sticky bit now on this directory. Okay, to do that, chmod o plus t, then the name of the directory or the path to the directory which you want to use sticky bit with. Done. Now let's check the permissions. ls space -ld slash share2. If you see, this last bit has changed to T. Since the permission, this sticky bit permission is applied on others permission, so again the execute bit will be changed to T once you set sticky bit on a directory. This small t means that this directory has both execute and sticky bit set on /share2. Okay, so I mean this /share2 has execute permissions for others, plus it has sticky bit set on it as well. Okay, if I remove the X permissions, then this small t is going to become capital T. Remember that, as shown in the example. Okay, so if I remove this X permissions from this directory, then this small t is going to become this capital T. So this is the difference between this small t and capital T. Remember this. And similarly, it is the same for other special permissions as well. All right. So now we have set the sticky bit on this directory. Now let's log in as a dev1 user once again. So I'll become dev1. Okay. Okay. And now I'll try to create one more file using the touch command. So touch /share2 slash. So let's name the file as dev1 again. The file is created. Okay. Now I am going to become dev2. So I'll log in as dev2. Type the password. Now I'm logged in as dev2, and now I'll try to remove the file created by dev1 user. This is what we want to stop using sticky bit. So let's see if we can. Dev1, right? /share2 dev1. So what I'm trying to do is, I logged in as a dev1 user. I created one file inside a directory which has sticky bit set. The name of the file is dev1. Then I logged in as dev2, and now I'm trying to delete the file created by dev1. I get the prompt again. I'll tap Y, hit enter, and you can see this time I get the message RM cannot remove /share2 dev1 operation not permitted. So I don't have the permission now. So after I set the sticky bit on /share2 directory, I was able to restrict the file deletion of the files by the user they don't own. Okay, so if you see, this file was owned by dev1, and when I tried to delete the file logged in as dev2, I was not able to do so because I set the sticky bit on this directory. So this is the whole concept and real use case of sticky bit. Okay, so question number 35 is how to find which process is using a port. Okay, so which basically means we want to find out for a certain port what all processes and their process IDs are associated. Okay, so you can use this command called lsof. Okay, so to do that, run lsof space -i space colon then the port number. So for example, I want to find out the processes attached to port number 22. Okay, I am getting an error, /bin/lsof, no such file or directory. It basically means that lsof package is not installed on your machine. So you can simply install it with yum install lsof space -y. It's installed. Now if I run the same command, I'm going to get all the processes that are attached to port 22. Okay, so this is the way to check it. All right, then question number 36, how to mount a file system with mount command. So we can mount a file system with a mount command with a simple mount, then the name of the drive or the partition that you want to mount, and where do you want to mount it. So let's just understand the concept of mount first. So what happens when you attach any disk to your machine? Okay, so generally what we do, either we use the entire disk to create a mount point, what we do, we create a file system first. Okay, so whenever you attach any hard disk to your machine, it does not become usable by default. You have to perform a few steps before it actually becomes usable to store data. Step number one is you have to create a file system on that disk. So it's up to you whether you want to partition that disk into multiple parts. You can do that, or you want to use the entire partition as one single storage device. It's up to you. Okay, so to check all the disks attached to your device, okay, I'm not talking about the file system, I'm talking about the disks attached to your machine. You have to use the command called lsblk. Okay, so right now, as you can see, only one device is attached, which is XVDA. It is of size 15 GBs, and XVDA has been partitioned into 4 parts. Okay, so what I've done is, I did not do it actually, it was done by Linux. So this is the default configuration. I'm using this Red Hat Enterprise Linux version 9. It's an AWS EC2 instance. So here I got this by default. So they have attached one volume. I mean, I attached one volume, but these partitions have been created automatically. Okay, and this is how they have divided this entire space of 15 GB to these 4 different partitions, and then these different partitions are mounted to different mount points. Okay, so I don't have any partition or any disk that I can use to create a mount point. So what I'll do first is, I'm going to attach one additional volume to this machine, and then we are going to see how we can make that disk usable for us to store data. Okay, I'm going to show you the step-by-step process, how you attach a volume and you make it usable to store a data. Okay, so step 1 is you have to create a volume. So I'm already on my volume dashboard. If you don't know how to do it, you can go from here. So on your EC2 dashboard, you can click on volumes, open it, and this is what the volume dashboard is. Okay, so I already have it open here in another tab. So let's use that, and let's click on create volume. Okay, I just want to use it to show you the demo. So I'm going to use minimum space, which is 6 GB is what I want to use. Availability zone is important because you have to keep your availability zone same as your EC2 instance. My EC2 instance is demo-EC2, which is in US East 1A. Okay, so I want to create this volume in US East 1A. Okay, once again, I have already covered these concepts in my earlier videos. I spoke about this in my EC2 deep dive video, so you can check that in the AWS for DevOps learning series in that playlist. So there's a video called EC2 deep dive where I've covered this concept. Okay, but just in case it has come up here, so you have to keep this volume in the same availability zone as your instance, which I have done, and the size is 6 GB, and then I'm just going to create volume. Step 1 completed. Step 2 is you have to attach this volume. You have to attach this volume of 6 GB. You can just add a tag also like demo-EC2 so that we are able to identify it. New vol. Okay, so this volume has been created. Now it's time to attach to the disk. I just created the volume, but I did not attach it to any instance. So I'll go to actions, I'll go to attach volume, and I'm going to attach it to my demo-EC2 instance, which is this one. And here I have to choose the device name. So here, as you can see, I already have XVDA. So the next name that I can use is XVDB. So I'm going to use XVDB /dev/SDB is the name that's going to come up here, and click on attach volume. As soon as you attach the volume, if you go back to your instance, if you run lsblk again, you will see an additional device listed there. This one, as you can see, 6 GB XVDB. So if you see here, this does not have any partitions because we did not create any partition. Okay, and this was done by AWS automatically. But for XVDB, it is just a plain device, plain hard disk with no partitions at all. Okay, so step 1 is complete. Step 1 and step 2 are done. Now we can configure this volume to become usable from here. So first thing I will do is I'm going to create a partition. So I will show you how to create a partition of a hard disk attached to your Linux machine. So for that, you have to do fdisk command. Space, then the name of the device, which is /dev/xvdb. Okay, this is the name. This is the accurate location of the device. It is /dev/xvdb. Hit enter. Okay, then you can type M to get all the options available to create the partition. Here you can see all the options, but to create a new partition, you can use N, which is to add a new partition. It's going to divide your hard disk into parts. So let's type N, hit enter. Then it's going to ask me if I want to make it a primary partition or an extended one. Okay, and let's go for the primary one, which is the default option. So just hit enter here. It's going to create a primary partition. Then you don't need to change anything here. Just keep hitting enter. Okay, it's asking for this partition number. So which is default one is 1. So we will use the default options here. So just hit enter. Then the size of the first sector, we don't want to change the sector size here. We don't want to do much. We just want to create this partition. Okay, just keep hitting enter until you get this screen, and it will give you a message. Created a new partition 1 of type Linux and of size 6 GB. Okay, I did not change the size also. So this entire disk has been created as one single partition of 6 GB. Then after you see the screen, to save your changes, you have to type W. So W is used to write table to disk and exit. If you make any error, you can always quit. You can type Q and it's going to quit without saving. Okay, but here I did not do any mistakes, so I can just type this W and hit enter. Okay, so you will get this message. The partition table has been altered. Okay, and then calling IOCTL to reread the partition table. So it's going to refresh the partition table for you. Now if I do lsblk again, you will see that XVDB has been partitioned into XVDB1, but I did not change the size, so it's going to take the default size of 6 GB. Done. But I haven't created any file system on this partition. So step 1 is to add the volume. Step 2 is to create the partition. Attach the volume. So step 1 is to create the volume. Step 2 is to attach the volume to the instance. Step 3 is to partition your disk. Step 4 is to create the file system. Okay, so let's see the existing file systems. For that, you have to specify -T along with small h to see the file system types. And as you can see, this root is the main file system. It is using XFS. So we can use the same file system type. So the next step is to create the file system. To create the file system, we have to use mkfs, which means make file system dot file system type. In our case, it's going to be XFS, and then the name of the partition that we want to apply this file system on, which is xvdb1. So you will get this message, which means the command ran successfully. Okay, so now this partition has XFS type of file system. Okay, now the next step is to mount the file system. So this is how this disk becomes usable in Linux. Okay, these are the steps that you have to follow. So now I'm going to mount this file system. Where I can mount it, if I do ls here, I will see one directory, new data. So I can mount this particular partition to this directory, which means that if I want to store data on this drive, I can store data in this directory. So whatever data I store in this directory, it's going to be stored on this particular device. Okay, the meaning of this. So to mount, you can see the command here also. So you can use the mount command. Okay, so mount space the name of the partition of the disk that you want to mount your file system on. So it's going to be /dev/stb1 space the mount point, which is /root/new data in my case. Enter. Sorry, use the incorrect name. So it's /dev/xvdb1. Done. Now if I want to check the mounted file systems, I can do df space -h capital T to check the file system type. And here you can see /dev/xvdb1 has been mounted on /root/new data. Okay, and it has the size of close to 6 GB. Okay, so whatever data you store in this directory, it's going to be stored on this particular storage device which we just created and attached to our file system. So this is how this mounting command actually works. Okay, I hope the concept is clear to you. If not, please reach out to me in the comment section. All right, next is how to check disk usage of a directory. Question number 37. So you can do du space -sh to check the disk usage size of a particular file or directory. So let's check it for new data, for example. And you can see there's no data in this, so the size is 0. Okay, if I just copy a few files, for example, if I do /etc/rsyslog.conf file to new data. Now if I run that command, you can see the size has changed from 0 to 4 KBs. Okay, so this is how you can check the size of a particular directory, okay, using du space -sh command. Next, question number 38. In which file do you permanently mount a disk in Linux? All right, very good question. So when you use this mount command, okay, which I used, these are the temporary mounts, which means that if I restart the system now, this mount point is going to go away. Okay, so to make this mount point permanent, you have to make an entry in one file. That file is called /etc/fstab. Okay, so to permanently mount a disk in Linux, you have to make an entry in /etc/fstab. You can go and check it, /etc/fstab. You can check what all is already there. So you can see these are the 3 entries that are there, and these are for our XVDA device. Okay, so similarly, you have to make an entry for your new device that you want to mount permanently. So after that, if you restart, it is still going to be there. That mount point is going to be there permanently. Okay, after you make an entry in this file. All right. Then question number 39 is how to search for error or failure logs in a log file. All right. So this is again related to Linux troubleshooting. Okay. So let's check the system messages. So by default, in a Rail machine, in a Red Hat Enterprise Linux machine, the system logs are created and generated in a file called var/log messages. So to search for any error or failure logs, you can just grab that keyword that you're looking to search like this using the grep command. So grep -i. Let's copy this command from here. Let me clear the screen. So I want to just search all the logs with failed text in them. Okay, so I'm using this var/log messages, which is the default system messages file. So I'm trying to search for failed messages, and you can see all the failure logs available to you. Okay, so similarly, you can use other keywords as well. Apart from failed, if you have some specific keyword to search, you can just grab for it in your log file like this. Okay. Then question number 40 is how to secure SSH access on a Linux system. So there are multiple ways to do it. So first one is you have to enable SSH key based authentication. So if you see in AWS EC2 instances, by default, we have SSH key based authentication enabled. We don't have the password authentication enabled because this is the most secure way of SSH access. Okay, so always try to use key wherever it is possible instead of using a username and password for your SSH access. Okay, so that's one thing for security. Other thing is you can disable root login as well. Okay, so for example, you want to save your system for any hacks, or I mean, if someone wants to hack your system with root account, so you can disable the root account login at all, which means that no one will be able to use the root account to SSH to your Linux machine. Okay, then the third thing is you can use another port. So by default SSH runs on port 22, so which is easy to identify for hackers as well. So to secure your SSH access to your machine, you can change this port in the configuration file. Okay, so you can use other port than 22. So let me show it to you, the file that has all these details. It's /etc/sshd_config. Once again, I already have one video in my same Linux for DevOps series where I've covered all the concepts, the different configuration files for SSH as well. Okay, so you can go watch that video to get all the details around SSH basics. So this is the file where you can configure all that, okay, which I just spoke about. So try to go through this file. Okay, here you can see this password authentication has been set to no, okay, which is the default behavior in an EC2 instance. Okay, so you can just go through this file and see what all options are available, what all you can configure or change to make your file more secure. Here I gave you 3 things that you can do to secure SSH access. Next, how to check authentication logs. Okay, so authentication logs are stored in a particular file depending on which operating system you are using. Okay, so here if I go to /var/log and list out the contents, I can see I have file called var/log secure. So here on Red Hat machines, you have this file called var/log secure where you can find all the authentication logs. Okay, so if I do cat secure, you can see all the authentication logs here. Okay, all the authentication logs are available in var/log secure, but in some operating systems, I think with Debian, you will find it in var/log auth.log, all the authentication logs. All right, then question number 42 is how to check files opened by a process. Earlier on, we learned about how to check the processes attached to a particular port. Similarly, LSOF can be used to check what files have been opened by a particular process. Okay, so what I will do here is, let me start a process, sleep process, and I'm going to run it in the background. So I use ampersand to run this in the background so that I get my prompt back on the terminal. Done. I see this process ID generated 6141. Now if I want to see what all files are opened by this particular process, okay, so I can use this command. So this was the question, how to check files opened by a particular process. So you can use lsof command for that. lsof -p space -p and the PID, which is 6141 in our case. So you can see all the different files that have been opened by this particular process here. Okay, so all these files have been opened by this single process. Then question number 42 is where can we check default DNS name servers in Linux? So your default DNS configuration is in this file /etc/resolve.conf. Okay, so you can do cat this file to check the information related to your DNS name servers. So this is the name server which is given by AWS by default. Okay, I did not make any changes to it. So this file holds your default DNS name server configuration. Next is question number 44. Why do we use -r flag while deleting the user? Okay, so let me check. I think I still have this John user. So John /etc/passwd. John is there. Now the question is, why do we use space hyphen r flag while deleting the user? So to delete a user, we can use a command called userdel and username. If we don't specify space hyphen r, what will happen is the user's home directory is not deleted. Okay, if I check now, user's home directory is still there. So his data is still available on the system, which is not the best thing to do. If you're deleting a user, it's better to delete his home directory as well, as part of the best practice. Okay. So now if I create another user del, sorry, I'll create another user add James, user created, and then I'll try to copy some files. Maybe I can copy John's file, John/star. So I'll copy all the files in the John's home directory to /home/James. After I created the user, this home directory was created automatically for James. Okay, I have to specify -r. Okay, let's come out of it. I think it was giving me this for the directory that was there. So let's just list out the contents of James home directory. Okay, yeah, it copied all the thing, but it failed when I was trying to copy the directory, so it gave me the message this one. Okay, but when I use this -r, because I'm still trying to copy all the contents from John's directory to James directory, so it was giving me the option to overwrite the already existing files which I don't want. So I have all the data available in James directory now. Okay, so now what I'll do, I will do userdel, and this time I'm going to use -r. So when I do that, it's going to delete the user's home directory also. Now if I do ll on /home/James, I won't see anything because this directory has been deleted. So no such file or directory after I use this -r option. Okay. So -r is to ensure that user's home directory is also deleted. Then question number 45 is, how can you monitor live system logs in Linux? So to monitor live logs in Linux, you can use the command called tail -f. Okay. So let's just see it in action. What I'll do is, I'm going to open another session of this same machine, and then I'm going to generate some live logs. Okay, so let's do one thing. Let's just try to follow live logs. So where log messages, here you can see it is showing all the live logs. Okay, the current logs. So let me log into this machine from another terminal and see what all logs are generated, and then we will see if we are able to see the live logs here on this terminal or not. All right, I'm logged into this machine with one more terminal, and here you can see some logs have already been generated. Started user session 7 of user ec2-user. Okay, as soon as I logged in, I got the another log. Now let's try to install some package. Okay, I was trying to install the package which is already installed. Let's delete the package and see if I am able to see some logs. So let's do yum remove, delete it, and here you will see I'm not sure if this is related to that service. So what I'll do, I'll try to install the package again. Install the package, and then So let's just start this service. So systemctl restart nginx. Okay, I have to be using sudo. I'm logged in as ec2-user, so sudo ctl restart nginx. The service is started, and here you can see the logs are generated. Okay, so nginx configuration. So all the system logs, because I haven't configured any specific logs for this service. So all the system-wide logs are going to be generated and stored in the var log messages file. Okay, so as you can see, as soon as I started the service, I got the live log here. Okay, so nginx started the nginx HTTP and reverse proxy server. Okay, so this is how you can follow the live logs using the tail-f command. Tail space -f, then the location of the log file that you want to monitor for live logging. All right, this is done. Then question number 46 is, a user is trying to execute a script, okay, using this command /script.sh that he created, and receives the following message: permission denied. How to fix it? So this only means that this file does not have execute permissions, because this script was created by a user, as it is given here. A user is trying to execute a script that he created, and he's still receiving the message permission denied, because the script has to have the execute permissions. Okay, so you have to attach the execute permission to the script, and then the user will be able to execute the script. So let's see it in action. Let me come out of it. Control C. So let's create a script. Let's do sc.sh, and let's use shebang for bash script, and let's try to echo something. Echo test. That's it. Okay, so this is the script that I just created, and if I try to run it, I will see the message, this permission denied. Okay, which means this, if you do ll here, you can see this sc.sh is actually owned by root. Okay, so the user permissions are set to root, the group permissions are also set to root, but this is a script, right? I want to execute it, so it should have execute permissions, which are not available. Okay, so neither the user or the group or others have execute permissions on this script, and that is why you got this message permission denied. To fix it, chmod u+x. I just want to give this execute permissions to the user, sc.sh. Now if I run the same command, I won't get the error message, and I'm able to run the script. Okay, so this is one way of doing it. If you want to still run the script without giving the permission to it, so there's a way to do it. So let me just create another script. Let's name it as sc2.sh, and once again I'm going to use shebang /bin/bash, and this time I want to echo new method. Okay, so the script is created. Right now, if I want to execute the script without giving execute permissions to it, so what I can do is I can supply the shell to it, like bash. If I do bash sc2.sh, I will be able to run the script. Okay, so if I do ll, I don't have the permissions assigned to sc2.sh. As you can see, sc2.sh does not have execute permissions, but even then I was able to execute it because I supplied this bash command to it. Okay, but if you run it like this, then you will see the message, error message. Okay, so bear that in mind. All right, then question number 47 is how to create a new local user group and add local users to it. So just like you can create a local user using user add command, similarly to create a group, to create a local group, you can use this group add command. So group add command is going to create a group for you. Okay, so here I've given the example also, so we can use the same one. So how to create a new local group, user group, and add local users to it. So let's just try to create this group called DevOps. Okay, so this command is going to create, okay, DevOps is already there, so let me create DevOps 2. The group is created. Then what I'll do is, let me create a user also. So let's do user add. Let's do engg for engineer 3. Created. Now I want to add this user to a group that I created manually. Okay, so I can again do user mod space hyphen small a, capital G, capital G, then name of the group, which is DevOps 2, and name of the user, which is engg3. Fine. To verify, you can grab that name of the user from the /etc/group file, which stores all the group information. Okay, so I can grab for it. So let's grab engg3 from /etc/group, and you can see engg3 has been attached, or has been associated, rather, not attached. Attached is not the right word here. So engg3 has been associated with DevOps 2 group, which I created manually. So this is the way you can create a local group and add another user to that particular group. Okay. Question number 48. Is Linux operating system virus free? No, that is not true. There is no operating system till date that is virus free, but Linux is known to have less number of viruses. So sometimes it's a misconception that Linux can never have viruses. So Linux can have viruses, but yes, it is more safer as compared to other operating systems. Okay. Then question number 49 is how to extend the size of a file system is in Linux. So I already took one example in one of the questions where I was trying to attach a new disk to the machine and then making it usable, where I created the partition, I created the file system on top of it, and then I mounted it. Okay. Here in this example, the scenario is you already have a file system. Okay. And the size of the file system is getting full and you cannot delete any file or anything from it. The only option is you have to extend the file system. This is a very common scenario. Okay. I've done it multiple times. The customer is going to reach out to you saying that he has some critical data to be fed to the server and the file system size is getting full, so please extend the size of the file system urgently. Okay, so in that case, these are the steps that you have to follow. So we'll follow all the steps and see this demo. So first thing is you have to extend the size of the EBS volume that is attached to your machine in your AWS account. Okay, so go here. So go to volume section and create an, sorry, don't create the volume. Just go to your instances and check for the volume that is to be increased. For example, I want to increase the size of this volume /dev/sdb. Okay, so /dev/sdb is the volume with volume ID 588. Okay, so I can go here and check for this one. So just choose this volume, click on actions, click on modify volume. So the first step is to extend the size on your AWS account. So from 6, let's increase it to 10. Rest, we don't have to change anything. Click on modify. It's going to give you the warning, just read through. Okay, and click on modify. So the volume of your the size of the volume has been increased on AWS. Step 1 is done. To verify that, you can use this command lsblk to verify. So what you can do is lsblk and you can see the increased size of xvdb. So XVDB size has been changed from 6 GB to 10 GB, but yes, we haven't included that increased size in our the partition. So the partition is still of 6 GB, but the main disk is of 10 GB. So 4 GB is still left to be used anywhere. Okay. So this is fine. Step 3 is run df-hd to identify the file system type. Okay. So do df space -h capital T. So we want to extend the size of this /dev/xvdb1 and it is of type XFS. Okay, so size is 6 GB, but the main volume is of 10 GB now, so we can increase it from 6 GB to 10 GB. So that is what we want to achieve. Okay, this is the file system. Remember, I want to extend the size of an existing file system. So AWS has given some commands from their end that you can use to extend the file system. Okay, how to do that? The first thing is you have to increase the size of the partition. If you see here in lsblk command, the size of the partition is still 6 GB, but it can go up to 10 GB. So we have to extend the size of the partition first. To do that, you can run this command, grow part command. Grow part means grow partition. Okay, I'll explain this command to you, how it is being used. So grow part, then the name of the main device. Okay, here this /dev/xvd is the main hard disk name and not the partition name, remember. Okay, so in our case it is /dev/xvdb, and then this number is the partition number. Which partition do you want to extend the size for? So in case of XVDB, there's only one partition, which is /dev/xvdb1. So we can replace this 4 with 1, which means that I want to grow the partition /dev/xvdb1. Done. You got the message. If you do lsblk again, you can see the size of the partition has been changed from 6 GB to 10 GB now. This is done. Now we will extend the size of the file system. For that, so if you're using XFS type of file system, then you can use this command, xfs_growfs -d. Let's copy this. So xfs_growfs space -d and then the file system mount point. Okay. So our file system mount point is /root/new data. So just copy this and replace it with this. So what it's saying is I have extended the size of the partition. Now I want to extend the size of the file system. Okay, so the file system's mount point is /root/new data. So run xfs_growfs space -d, then the file system mount point like this. Enter, you will get this message, right? To verify, you can run df space -ht, df space -h capital T. So now you can see the size of the file system has also increased from 6 GB to 10 GB. This is done now. Okay, so your file system size has been extended from 6 GB to 10 GB. So these are the steps that you can follow to do that. And this is again a very important question because this is like a normal day-to-day task that you can get, okay, while you are working in real time. All right, then question number 50. How to find something on a Linux machine. So to find something on a Linux machine, you can use the find command. Okay, so for example, I want to search for a file. Let's search for a file in the root directory. So what you will do is find. Where to find? I want to find something in the root directory, means I want to find on this entire system. Root is the main directory where you store everything on your Linux machine. So I want to find something in the root directory. Then what I want to find, the name of the file that I want to find is sc.sh, for example, and run this and you will get the path of the file. Okay, so if I get this file, I can see this file is present, right? So this is how you can search for a file on Linux machine using find command. But yes, If you do man find, you can check all the different options that you can use to do find. So find is a very important command, and it can be used in multiple various ways. Okay, as you can see here, all the different options are available. So please explore if you have enough time. Okay, in this example, I just wanted to give you some introduction into this command. This is one of the most important commands that you will use in your day-to-day life. Okay, so you can see a lot of different options are available with find command as well. All right, guys, that's all I wanted to cover. I covered 50 important Linux questions and answers with all the hands-on demos and explanations. I hope this video was useful to you. Okay, so these are some of the most important questions that you should learn before appearing for an interview. But yes, Linux does not end here. Linux is like an ocean. Even if I cover 500 questions, it won't be enough to cover all the things in Linux. Okay, but whatever I thought of is important, I covered in this session. I'll see if I have enough time. I'm going to come up with some more questions and answers like this. Okay. All right. I hope you liked the video. If you did, please hit the like button. Please share it with your friends and colleagues, and please do subscribe to my channel. It really motivates me to make more videos like this. And if you have any suggestions, anything, or any topic you want me to create video on, please put it in the comment section. I'll be happy to do that. All right, guys, that's all for this one, and I'm going to see you in the next one.